Hello everyone, my name is El-Ateif and I am a machine learning engineer and ML pathway mentor at STEMway. So today I'm going to talk to you about how to build and Dockerize a web app of your machine learning model. So I will get started with some key terms so we can get familiarized with them. Machine learning, then I will explain a typical machine learning workflow. I will talk about the process workflow, like what I did overall in this process. Then I will do a quick demo, and we will move on to the questions, if you have any. So in the machine learning pathway, what we did in level 1 was the following. So we tried to collect data. We scraped data from the Discourse Hub community forums. We explored our data by performing some exploratory data analysis, so we can understand our model, so we can understand our data, and then try to model them. We trained some simple machine learning classifiers, so we can classify a post into its appropriate category. We then trained the bert-model, one of the super classifiers in the natural language processing field. We evaluated our models and chose the best approach. Then, to wrap up, we built a simple web app using Flask or Streamlit, which I'm going to show you today. All right, so first things first, what is Docker? Because, as I told you, today we're going to actually build a web app, then actually Dockerize it. So what is actually Docker? So simply, Docker is just a platform for developers and system admins to develop, deploy, and run applications with containers, which is often described as containerization. So now, in simple words, what is Docker? So Docker is just like the perfect environment for your app. It has the libraries needed by your app, the dependencies, and any kind of file your app may need. But then it is lightweight. Like, for example, a lot of people confuse virtual machines and containers because they kind of like look the similar way, but it's different. As you can see here, a container uses the host operating system. Like, for example, if you're deploying this on the cloud, it's going to use the cloud resources and the cloud operating system. While virtual machines have hypervisors, so they can use any kind of systems that is going to be installed on them. For example, if you install your virtual machines, you have, for example, a Mac system, and you want to put in a virtual machine a Windows system or Windows OS, then you will be able to use it in a virtual machine. But containers aren't like that. Like, you can't install a system in them. You can't install a Windows or a Linux or whatever you want in them. They actually directly use the system that you have in your laptop or wherever you are going to deploy them. So that is the huge difference between these two. And of course, containers are lightweight, while virtual machines are extremely heavy because they require a lot of computing power. So how does the Dockerization process work? So what we do is just we build a Docker file. It's just a simple file that has where you try to install, like, for example, usually when you are developing a model, or when you are developing your own model in your system, a good practice is to actually build an environment for it, then install the libraries you will need, or along the way you figure out kind of libraries you will need when you are building your model. So all of those libraries that you have installed and anything that you have tried to install will actually figure out in that Docker file, along with, of course, the environment that your app needs to live in that Docker. So after you have actually written that Docker file, you will build it. So when you are going to build it, the final output is going to be a Docker image that then you can run on your own system just to test that everything is fine, it's working, your app is working as it should be. Then you run it, of course, to check if everything is all right. And the final result is going to be called, if everything is all right, of course, a Docker container. That's it. It's as simple as that. All right. So we'll be using Flask, and we'll be using Streamlit. So Flask is a Flask framework is a micro web framework, okay, written in Python. It's actually classified as a macro framework because it does not require particular tools or libraries, not like, for example, Django and all the other super interesting web development tools, because it does not require, of course, any kind of libraries. It has no database abstraction layer, form validation, or any components where pre-existing third-party libraries provide command functions. So it's actually just a lightweight web development tool. That is what Flask is. You can either use it to actually build an app, like, with HTML and CSS, or you can use it to build a simple API, which is quite great for the machine learning community, because most of the time we do not actually build apps, but we build APIs so that developers can use them in their apps. So there is another tool that has impressed the machine learning community because it's much more beautiful and easier to build, to build a simple web app that everyone can try and interact with instead of just using the command line, which is Streamlit, and it's an open source application framework for machine learning and data science teams. And it creates beautiful data apps in hours, not weeks, all in pure Python, which we will be seeing in the demo. All right, so what is machine learning project workflow, like a typical one? So usually in machine learning, we just collect the data, try to apply some pre-processing to it. Of course, there is visualization to try to understand your data and try to clean it. So after the pre-processing is done, you prepare data. Then you apply learning algorithm to your data. That is the machine learning part. So you have to apply machine learning algorithms to try to learn something from your data, model it so that it will be easier for the machine to learn and apply, the task you wanted to apply to. Of course, then you evaluate it and all of that. Then you deploy the chosen model, the best performing one. And after that, you just, put it in an application so that it can be used in production. Of course, this is an iterative process. At any kind of moment, you can go back to a certain part and then repeat it until you get the results you need. All right. So what are we going to do? What did I do when I tried to build this app? So the first things first, obviously, is to build the machine learning model. Then I wrapped this machine learning model in an API for Flask and Dockerized it. But for example, for Streamlit, I didn't use any API. I directly coded the Streamlit part, which really it's not much lines. Well, at least in comparison with the Flask one. I Dockerized it as well, then run the app locally. So for now, I didn't deploy it in actual, in the cloud or anything like that. Not because I can't or that it is difficult. It's pretty much easier, actually. You just have to put all the code in your GitHub and push it to Heroku. Heroku, for example, will take care of everything. Even Netlify can do that for you. But because here I'm using the bert-model, because you will find many machine learning examples, using simple algorithms, but very few examples using advanced algorithms like BERT or any of the super state-of-the-art models. So I tried to use BERT, but the thing is, for example, if I tried to put in Heroku, it is too heavier. The wrapped up model I'm going to show you that you will need to generate to put in your app to do inference is just over 500 megabytes, which is the limit for the free Heroku, for example, part. Yeah, so I didn't deploy it. But you can, for example, change the model like from a BERT one to logistic regression, decision tree, or any of the simple ones, then deploy it to Heroku, and you can play around with it and give it to other people to play with. All right, let's get to the demo part. So I put everything in my GitHub. Like I put the project in my GitHub account. So you can go clone it, like using this link, or you can just download the zip and then play around with it. So I already have this code inside my own laptop. I will try to first show you the Flask version, then the Streamlit version. But before that, remember that first things first, we need to actually build the model. So remember to build the model so you can get like the wrapped up model, the one that will be actually put in a pickle file, so you can use it for inference. Because I didn't put it here in GitHub, seeing as it is really too heavy for GitHub to load quickly, and I really have a bad internet, so I can't afford to put it out there for you. Sorry. Okay, so I'm just waiting for the the notebook to load, so I can show you around like how to train a BERT model. I hope it's gonna open up quickly. Otherwise, we can just open it in Colab. All right. Okay, so for you, you can directly open it in Colab, then select, like change runtime, select GPU, so you can train BERT faster, otherwise you will stay the whole night or something like that, because BERT usually takes a lot of time to run. All right, so the library I use here is Simple Transformers, which kind of takes what Hugging Face had already done and makes it like hides all the complicated parts and helps you train quickly the model, like for classification or any kind of task you're interested to do. Remember here, we're trying to actually classify a certain forum post into a certain category that belongs to a certain forum. So here, the data I am using has been scraped from the Amazon forum. It was scraped in June 2020. So when I go back to the forum and pick a new example that has been generated in 2021 to test the model, you will know it's the new data it hasn't seen before. All right, so I'm going to use Simple Transformers. Nothing really too complicated. I just installed the actual library. And one of the things you will have to do is that you have to install the Dockerize. So usually it is installed by default, but the version, because Simple Transformers has been updated. Sorry, I mean the Dockerizers the Dockerize library has been updated by Hugging Face. So we can't actually use the new one, as Simple Transformers use the 0.9.4 version. So just install this one, and after you do this pipe install, make sure you restart your actual, runtime. Okay, so I'm just getting the data. You can do the same from our GitHub level 1 machine learning repo. Then after this, we will load the data that was, download, and we will try to do simple preprocessing with it. So, for example, here I choose to keep only the title, leading comment, and reply comments, so I can try my, train my data on it. You can choose to put all of them together and see how your accuracy is going to either go down or go, go up. So we have, if I remember correctly, 11 categories in that Amazon e-commerce forum. As you can see, we have some serious data imbalance, but I didn't try to do anything about it because that wasn't really the interest in this, in this part. So Now, what I'm going to do is just to do some simple, very, very simple cleaning, like data cleaning, because usually BERT actually can take care of all kinds of data, even if there are emojis. BERT understands them. So there is not actually a very pressing need to clean the data or do any kind of data formatting, but I choose to clean up any kind of signs just to stay safe and have a better, better looking text for the model to easily train on. I of course choose to remove any kind of HTML tags if they are left from the scraping, even though they should be known, but you never know. So I lowered the text as well, and as I told you, I tried to get rid of all of these signs that could pop up in the text. Okay. So after I applied this function that will clean my text, I just applied this kind of string thing, tried to transform all the text in string, because you will be finding some numbers, like for example here, toolboxes, and when you try to train the model or do anything on it, it's going to complain. That is why I apply this here. And I, of course, renamed the columns into post and category. You can either rename it, for example, test, label, whatever you choose is going to stay the same. All right, so after that, I transformed my actual categories into numbers, because this library doesn't really take care of that part. There are other libraries that quickly take care of it, for example, TensorFlow. They can do that, quickly. Of course, I could have used TensorFlow, they wouldn't have been a problem, but then what we were interested to use was PyTorch, so yeah, here we go. Okay, so after transforming these categories into numbers, as you can see, mapping them more likely. So after mapping them, I just tried to split the data. So I used the sklearn model selection one, where I split the data into 90%, 10%, so 90% for trained data and 10% for the test data. As you can see, we have 70,093 row for the train and 789 for the test. It should be pretty good. So we will build the model by first some training arguments. If you want to, fine-tune more ones, you can just add the ones you want to fine-tune. I just put for the number of training epochs 4. Usually that is the best one. 4 is the maximum you can go for a pre-trained BERT if you want to do transfer learning. That is the most advised. Do not try to go over 4. It won't be it may even go bad, your accuracy may drop, the performance may get better instead of better. So 4 is good, but you can fine-tune the other parameters like the sequence length and anything apart from the epochs. 3 to 4 is great. Over that is too much. All right, we create the classification model from the simple transformers library, and I will be training bert-model. And most especially, I'm going to focus on BERT base in case, because as you saw before in the pre-processing step, when I was cleaning the actual text, I actually lowercased it. So there's no need for me to use the cased version. That is why. So this here number of labels is actually just the number of classes that I have. Like I told you, I have 11 categories. And then, of course, I'm passing to add the train arguments. All right, so it's going to download the BERT model. And then we will train the model. So like I told you, we are training for 4 epochs. As you can see, you simply just call model.train model and when you're training data. Thanks to simple transformers, it's made easier. Otherwise, it would have been a long, long class that we would have defined. Okay, here, because the simple transformers library doesn't have F1 already defined, the F1 score already defined. So we are just defining it nothing too magical. We're just calling it out from sklearn and then passing it as a function. Then we will pass it to our model. So as you can see, F1, we call out our F1 function we just defined. Then for the accuracy, seeing as it is already defined, We just call it out. And of course, we're going to evaluate our model on the testing data. So we pass all of these things to result, model outputs, and ROC predictions. So ROC predictions, if you were interested to know what has gone on, like where did your model commit like some mistakes, you can check it out. All right, so in results, we will have the usual, like the ones that Simple Transformers library provide by default, which is the accuracy, evaluation loss, then the MCC metric, and the F1 score. Usually MCC is very, very like popular these days with multi-class classification, even binary one. You can use it. Like, yeah, it usually gives a better sense of what is happening with your model performance than all the other metrics. But you can of course try all of them. As you can see, for example, here, our F1 score is 74%, but our MCC is 69%. You can still fine-tune like the model and even get more data so it can perform better. But here, the more like the problem that if you could solve would give a better performance is the actual class imbalance I talked to you about before. All right. So now we train the model and everything, but we need to save it so we can use it in our app. So this is what we're going to do. We're going to save it as a tar file. Okay, so we will the actual where you will find everything that is needed by the model is put in outputs. Like that is by default programmed in Simple Transformers library. So save everything that is in outputs into some kind of folder, like I called it Amazon Forum BERT category classifier, I guess. All right, so then you remove, of course, just so you can keep everything clean, you can remove the outputs folder as you already saved everything in your compressed folder. So now we will test the model on a real example. Great. Now, as you can see, usually all of these libraries, we have already defined them before. But treat this part as if it's a new notebook, like it's a new, a new notebook or a new PY file. Just so we can test and make sure that everything that we need, like when we are building, for example, the API is really there. Like all the libraries we need, we define them. All the things we need from the model, we define them. So we can make sure that everything will work out when we build our API. Okay, so we import, of course, the interesting libraries that we need. So here we're just going to unpack the model so we can take everything that we have saved before from the outputs folder. We, of course, will again redefine the actual model, like here the class that has the model, with the parameters we had before were used in training. So we will use them again. Obviously, we performed pre-processing, cleaning. We have to clean out the text that we will be passing to our data. Great, now it's time to test. Oh, remember to add categories of course, as remember we had changed them to numbers. So you need for your own self as your user to know the actual name of it, not the number. All right. So here is a pretty interesting mistake I actually did when I was testing at first. Like I only gave it the body of the text. So as you can see, so this is actually a Flowster specific, like it was labeled as Flowster specific. But then my model actually said it was selling on Amazon. And here I was just playing around with the input one. Like, for example, if I asked my actual user to fill in the text, what it would be, like what would it be? And of course, the model did another mistake. It was actually account held. He predicted as selling on Amazon. And that's all because actually I didn't ask for the title and then the text of the actual post. Because remember, I trained my model by using the title of the post, the actual leading comments and the reply comments. While here, the reply comments won't be needed, as what we want to know is, for example, we just wrote a searching, we were thinking about writing a searching forum post and you want to know what category it belongs to. So yeah, there is no need to actual reply comments, but the title and the body, I need them because I trained my model like that. So he remembers that kind of shape of the data. So if we can provide them, we should provide them. That is why I provided this time the forum post title and the actual body of the, of my forum, of my post. So I'm concatenating them as I did in, when I was training my model. And I ask my model to perform the prediction, and it is getting them right. Yeah, it's finally performing well. So I tried another example as well, and it got it right again. Isn't that great? All right, so now that we built our model and got the actual Rapid app in a folder so we can use it when we are going to build the API, let's go and build that actual API. All right, so I'm going to just show you directly what I did. So I just started with the Flask version. Here you go. All right. So the API, so to build the API, what do I need? Remember, I need the model. I need to load the model and all the things I need from the model. And then I need something to call that model so I can perform prediction. And of course, my app has to take from the user the title of the post and the body of that post so it can perform the prediction. Great. Now, what I did was wrap, usually this is what we do, we wrap up the model in a 13py file alone, and then we develop the app part. Sorry about that. Great. So here's the model. I actually didn't do anything magical. I kept the part where I tested the model, where I told you this is where I'm going to do inference. So I took it as it is and reproduced it here. I took all that code and put it here. I didn't change anything apart from perhaps call. I just changed the predict part. I made it rapid it up in a function just for it to look nicer when I'm calling it in the API. All right. Now the API part, or the app part. Okay. So here I go. So this is Flask, it's not too much difficult. So for example, when I'm going to launch my app, it's going to directly take me into the home.html. So I tried to actually build a wall app, one with the front end. And this one, and this part is going to be the back end. So we can play around with it, but you can completely just use Flask as an API standalone, and then you will not need at all this home stuff and all of that. You will just need to call out to your actual, model the predict, so you can perform prediction using the post method. And because actually in my app I am taking stuff from a form, the post title and the body that I need from the user. That is why I have here if requested method is post, and I am taking stuff recuperating them, getting them from the form, for where the user filled it. All right. And then of course, like I did before, I'm just concatenating that thing because I didn't concatenate them when I was actually putting it in the model.py file. I just asked the model to get the post already. Everything should be preprocessed in the API. And that is usually what we do, any kind of preprocessing that is going to happen in the front end part, just put them in the API. And model, leave it alone. Try to make the model as lightweight as you can. It has only model stuff. All right, now the prediction, of course, I'm going to call the model so it can perform the prediction on the post. Remember, I called my py, the py file that has the model stuff. I called it model.py. That is why we are importing it as a module called import model. Great. Now I am going to send my, my result from the model to an actual HTML page so I can show the results to my user, and I called it result.html. And of course, I'm going to pass it the prediction that was done by the model. Great. We're running the app in a localhost format, or wherever you are, it's going to be localhost for them. But we don't use 127, etc. We use the 0, the 0, the 0, so that it can be like localhost for anywhere. It can be either an IP address or anything like that. And the usual port is always 80 or 8080. And I am putting here debug true just to see if any kind of thing is happening when I was building it, so I can debug and then, try and get rid of any kind of errors. I'm going to run this for you before I show you how we wrapped up everything in Docker file. Okay, so let's check out the README. Oh, this is strange. Guess the README got changed. I will change the README file for you later on. But for now, like usually the README should contain all the details. So let me just see if the README I have in my, my folders. Okay. README. Oh yeah. So I guess I didn't change the README. I guess I didn't change the README for the Flask version. Yeah, I didn't change it. Sorry about that. Okay. All right. No problem. I'm gonna change it later on for you. But for now, let me just turn this here. Okay. So I'm already changed into the foreign post classifier that, remember, you can clone and just turn the following. Like usually now what we should be doing is just, let me check out everything is already in here. Okay, so because I'm going to run the Flask version, I'm going to log into the Flask version, so everything, you can use everything there. Okay, so this is my model, the one that I saved into a tar file. This is the app.py. I'm going to discuss the Docker file later on with you. And this is the model wrapped up in here. This is the static part, like, styling for the home.html and result.html. Great. Let us run the Flask app. So Flask. I hope that was the command, because I usually tend to forget these things. Oh yeah, all right. It is working right now. Let's just wait a bit. It takes a lot of time. Strange. Okay, let me just test if it's already working. 127.0. Let's see, row that one. Normally, this is where I'm going to, oh, wait. I guess it's still running. All right. It took its sweet time. Okay. All right. So here we have like the front end app. So remember, we need the title of the post that you want to, to be categorized for you by the model, then the body or content of your post. So I'm going to go back to the Discourse Hub forum. So Discourse Hub, yeah, community. Great. And I'm going to directly sorry about that. Seems like my internet is acting up again. Yeah, my internet is pretty bad, sure. All right, no problem. I'm going to directly go to the Amazon forum. Why my internet takes its sweet time to figure out what is happening. Okay, so Amazon. Here we go. Okay, so I'm going to visit the site. Let me just check I didn't get disconnected. Okay, I guess everything is still right. Okay. Let's wait for the farm to load. Great. So I'm going to check out, like the latest one. Okay. So perhaps we can try this one. Guess it didn't get, it's something new, so very few text, but we can try. Yeah, let's try. Alrighty, so I'm going to fill in for the title we have selling. Okay, did it get copied? Great. Okay, let's copy the other part. The body. And test everything. Okay, here is the body. Okay. Great. Okay, so you can see what is happening. I'm gonna put this here for you. Let me reduce the size of this. Okay, great. That is why the back is great. Okay, so I'm going to click on predict button. Okay. Let's wait. So it's going to first get that model and load it. Then call it out. So it needs to extract it because actually the format that the model is in, the pickle file, is just like a kind of compressed form of the model. And usually actually the model loses a lot of accuracy when it is kind of wrapped up in this kind of compressed versions, but it still performs a little bit, it still performs good, but yeah, not as much, not like when you have trained it in your notebook. It's not going to be the same. Well, it actually loaded the model pretty fast, as you can see. And now it gives us the actual inference or prediction. So it is saying that my post falls into the selling on Amazon category of the Amazon e-commerce forum. And as you can see, it indeed is true, as this is part of the selling on Amazon. So perhaps the word that helped it make the prediction is this selling thing, or perhaps, the numbers. You could try and figure that out as well when you try to understand what is happening in your model. But as you can see, actually this /predict is just the result.html page, as I will show you. So this is the what was coded in the actual page. So we have this kind of text, and then we are expecting the prediction from the model. As for the home one, it will stay the same as the one I have seen you, because it doesn't expect anything, it's just pure HTML. But here, we need something from the model, so we coded it as well. And let's check out the source just so you see how it's coded. Great. So this is the source. So this is, of course, we are logged in style CSS. And this is just like what you saw, the header, the huge title, H1, this is the header part. Okay, and then the results, like I put them in a div class. Of course, we are calling out the prediction like this, as you have seen printed. And then I'm just like pointing you out to the forum if you are interested to check it out yourself. That's it. Okay, so now that we have run our, our API and everything is working great with the API, what we're interested in right now isn't the actual API. So we're interested to wrap this model in an actual Docker file. Right. All right. Let's go check that API, like the API that works well. How are we going to Dockerize it? Okay. So when I was trying to install my model, make it work, I used the virtual environment. And with virtual environment, I use this called post classifier. I installed PyTorch, as you can see here. I installed PyTorch, and I installed the simple transformers library, the tokenizers, the one I told you to specify the version. And of course, I installed Flask because it's the one I am running my app with. I did call all, these are all the libraries I needed for my model. And that's what I'm doing here. First thing first, I'm telling my Docker file that I'm going to use Python 3.8 version. The version 3.8. And in this one, it's better to use this slim buster, not just the 3.8 one like that, because it seems like it's in some kind of error. Not sure from where it comes, but yeah. Okay, and then I'm putting this line here, which prevents Python from writing out pig files. Another line so I can keep Python from buffering. And I'm installing the system dependencies, and this part is especially good for the Docker one. It's similar to what happens in Linux. Usually you have to update your libraries. That is why we're an app.get, get update. Yeah, you're of course updating the stuff that you need from the C++ library to make things faster. Remove anything in the server, will install the libraries that we need. Remember, I told you I start PyTorch. That is what I'm doing in this one. So there is no actual pipe install PyTorch directly like that. No. So you have to get the one from the repository. That is why we have such a huge line. And then I'm telling my Docker to keep to keep nothing in cache, to get rid of everything that is going to happen. If there is anything that is going to be stayed in cache, to get rid of it. I don't need it. It's going to take more space. And make the Docker slower. All right. I am putting all the code I have in Flask version folder. I am putting it in the Flask app, which means the requirement.txt that actually contains all the other libraries I need to install. Remember, there is still the simple transformers, the Flask library and all of that. So I put them in a requirements.txt to not bother with them. But the Torch one, when I put it in requirement.txt, something seemed to happen. I still don't understand what is the problem, but yeah, that is why I tried to split them. So This one I'm running it like for myself, just to make sure that everything that has been in Flask version that needed to be transferred to the Docker has been transferred. And mainly, of course, it's going to be the model that I compressed. And that needs to be decompressed when I am running, like when I'm running the app. All right, and this entry point is just like, for example, if you were running it inside your own laptop, you are going to click Python app.py. Even though, for example, here it's going to be Flask run, but you can, of course, either call Flask run or you can call Python app.py. Actually, that's why I forgot the command, because usually I'm just using Python app.py. Great. So that was the Docker file. All right. So one of the things I want to say about Docker files, please be careful about them. So run them, make sure they run well, and make sure they have got all the files that are needed for your application, and all the libraries were installed correctly, and everything is running as it should by testing everything by yourself, so that you can make sure it is running well and there are no problems before pushing it in a production environment. Okay. Now, let's say I want to run that Docker file. All right, just give me a second. I'm not sure what happened to my... Like, I feel like, yeah. Okay. Okay, so this is for Streamlit. Like, this is my README for Streamlit. Until I find what happened to the README for Flask version and put it out for you, I'm just going to steal some commands from here, even though they aren't the same. Anyway, so, okay. So what we're going to do right now, like, just if you want to test it by yourself, you can try it out. You will have to build the Docker, remember, so we can have the Docker image. And after building it, you will have to run it to make sure everything is working all right. And then you can deploy it. You will have your container and you can deploy it. Okay, so I'm going to do this for you for the Streamlit part, so it doesn't take much time. The Flask version is the same. You're going to repeat the same things. It's just that what you're thinking exactly is going to be different. Like, you can name it differently. Make sure like you provide an interesting name or something you can remember what you did with. Okay, so let me go and try the Streamlit version for you. Okay, so let me first open the code for the Streamlit version. Then I will run the Docker for it, so you can see it. It's going to be pretty much similar. So before that, I just want to show you. All right. Okay. I want to show you the Docker file. Okay, as you can see, I didn't change anything up above. Nothing. I just changed the name, the way I wrote the name of the the folder where I put everything. Here in the Streamlit version folder, just remember, just going to be the model. I'm loading the model. I am loading the model.py, like the model, the one we compressed. The model.py, the one that contains, like the one that is going to call out the class of our model and the prediction method. And requirements.txt, I'm going to show it to you like what is in it. So these are the things I need. So I'm copying all of them inside Docker. And there is actually no real difference between this one and the other one, apart from this part and here. That is normal because, for example, the Flask one, like the Flask API, uses the port 5000, But for example, for Streamlit, the usual port, you can change it, feel free. It's 8505 as 500 watts, sorry, as you can see here. And when you're running it in your terminal, it's going to be Streamlit run, then the name of your P5 file that contains the whole app, or the Streamlit code, the front-end code. Okay, so quickly, what's in the front-end code? It's similar to what was in HTML. Okay? So first things first, I, of course, import the necessary libraries, the model that is going to perform the prediction, then the Streamlit, the Streamlit library. I am, of course, predicting, I am calling the prediction function. I just wanted to wrap it up in a function again, but of course you can directly call it out without all of this fancy stuff. All right, I'm just putting the title just so that we understand what is happening. Oh, sorry. Seems like I didn't change the title here. Let me do it quickly while we're here. So it's, all the resources I used to build this stuff are referenced in the README files if you want to check them out. So you can use them later on as a reference you're out of. So this is a post for classifier. Great. That's it. All right. We're commenting the changes. Great. Oh yeah, I'm just telling the user what is happening, what they need to fill in and what I'm doing here. Then I'm asking my user to fill in the title as in the HTML part. Then I'm asking them to provide me of the body. Everything is the same as the HTML, just now it's nicer here, as you can see. I just need to write it. There is no need for me to code a lot of stuff behind the scenes. I am, of course, concatenating the post title with the post body. And then I am, of course, submitting, I am creating a submit button called predict so that when my user clicks on predict, I'm calling the model out here. That's it. And of course, I am printing out the results. See, pretty easy with Streamlit. Great. So before I run the Streamlit version for you so you can see it, and it's going to be prettier than the one I built using HTML. Sorry, I was too lazy to to make it more beautiful with the CSS stuff. So here's the requirement.txt file, the one that has the libraries I need. So like I told you, I need Dockerizers, I need simple transformers, I need beautiful soup because I used it, so I can, get rid of the HTML tag. You can remove it if you want, it's not really that necessary. And I need this LXML library for the beautiful soup 4, because I guess something happened in the library already provided by Python. So I needed to add this one, to remove the error. And then, of course, we need Streamlit as we are using Streamlit. We need to install it, of course. All right, the Docker file, as I showed you, didn't change much. And this post cat.py is the actual app.py, the one that has a Streamlit code. Great, 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 great. Okay, so I'm not going to run the Docker file now. What I'm going to run, though, is, of course, the actual application, the Streamlit one. And then I will run the Docker file for you. So one of the things I want to say here, of course, you have to run the pipe install requirements.txt inside your environment. Of course, here, if you are going to run it without the Docker file, make sure you are installing PyTorch if you don't have it. Great. I have PyTorch, I have everything installed in post classifier, so I am going to directly run the Streamlit part. So you can see the result. Oh, look at this. Oh, sorry. I forgot to actually change the directory. Oh my god. I always forgot these things. Okay, now I can run the actual Streamlit app. Yeah, what I love in Streamlit is that it's always reactive. But the thing is, when I actually put it in the Docker, like when I Dockers the whole app, when I'm trying to, like when I click on predict, it takes years. I'm exaggerating, of course. It takes a lot of time, and I still even after whole hours, I still don't get the prediction. And that is actually why a lot of people aren't using Streamlit directly, because it's not really that optimal when it comes to running models. It still needs to be updated behind the scenes so its engine can become faster. And actually, like many people, even with the Flask API, people have changed to Fast API, because Fast API uses the Unicorn engine. Anyway, it has a strange name. But the Flask API uses another engine that is slower than that engine. So yes, I do recommend you to use the Fast API when you are building machine learning models and wrapping them up. It's pretty similar to Flask API, no changes, like no real huge changes, but it runs, of course, faster. But the coding is going to be pretty similar. Okay, let's try the same example. Okay, so the title, here it is, the body as well. And as you can see, the Streamlit app is better looking and didn't even take me much time as the other one. All right, I will click on predict and we will wait for the result. So it's running, as you can see. Let us wait. Running. And as you can see, the Flask API is faster than the Streamlit one. Okay. I guess we will just have to wait. So while it is running, let's check out what is happening behind the scenes. So as you can see, okay, let me just reduce this one for you so we can keep both of them here. It is actually, decompressing the model because it was compressed in a tar file. So it is decompressing it first, then it will call it to perform the prediction, and of course, it will give us the result. As you can see here, it gave us the result, which is your forum post falls in the selling on Amazon category of the Discourse Hub Amazon e-commerce forum. Isn't that great? Yeah. So our model performs well and everything. Now to the dreaded part. Let me just quit this. So Control C, let clear all of this. And then I am going to call out the Docker file. All right. First things first. My Docker file has already been built. I am just going to run it for you so you can see it. Let us go back to the README. All right. I'm going to use this part, running it. Great. Here we go. I'm running the Docker one. Building it is actually easier if everything is all right. Like, you shouldn't worry. It's going to be... It takes a bit of time, actually, to build the Docker file. That is why I didn't run it, because it will take a lot of time. But running it takes less time, usually. And I already gave you, like, all the troubleshooting, like this part here, or the troubleshooting you may ever need. At least these are the ones I used to troubleshoot with Docker. just remember to be very careful when you are running it and see if everything has been actually put into your Docker, the libraries needed, the files needed when you are building it. Like, these are my actual advice when you are pushing them. So for example, here I didn't deploy my model, as I told you before. It would have taken much more space. And even if we could of course succeed in putting it into Heroku, but we won't be able to run the model. Like, we won't be able to see any prediction. I already had a bad experience with another model that was like 500 megabytes, pretty similar to the one I have now. And yes, we succeeded in deploying it in Heroku, but when we tried to run it, we got no prediction. That is why we ended up putting like the Docker app wrapped up in, like, we put it in, of course, we have deployed it already in Docker Hub. Like, that's where you can make your Docker public and everyone can install it and build it and run it, of course, inside their laptop. I mean, run it, no building, as you have already built that. And when we put it in Docker Hub, we put it then in Azure, like we deploy it in the cloud, so we can get the actual prediction from the model. All right, so here, as you can see, I have launched my app by running the Docker that has everything that is needed for the app. It's taken a lot of time as before, and I'm not going to test the prediction for you, as I am sure it's going to take a lot of time, and we're not going to get any result because it's too slow to use Streamlit or these kind of things. So remember, if you wanna do, like, if you want something like, if you wanna wrap up your app somewhere, please do not use Streamlit if it's not for demonstration and just to play around with. If you're serious about your deployment, please use something more professional, like Flask API or Fast API, whatever you want, but please don't use the other one. It's going to take a lot of time to run. Of course, it's not the best one for, it is not really the best one for production, of course. Usually in production environment, you always want something that is really, really fast. Okay, let's see. It's still running, as you can see. Okay, so that was it, like, for the part of deploying your, like building the web app and then Dockerizing it, and of course making it, available at least locally after you have wrapped it up. Let me see if you have any kind of questions I can address. Sorry. Let me stop sharing my screen first, and then I will check out your questions. Okay. Seems like you have no questions, I guess. To send to me if you have some. Oh, right. Let me share my, the project GitHub with you. I will try to actually fix some things, like put in the actual README for the Flask API. The real README. Oh. Seems like I can't copy. All right, great. Here we go. Can we have the results in the same page for Flask? Yeah, sure. You can do that. Nothing's like stopping you from doing it. I just like coded each one alone, but you can have the same results in the same Flask API. But usually, like people use Flask API Flask just to build the API part, and not the actual, like not the actual front end of the model. Because like in production, people want to use either a mobile app or some other advanced framework for it, like Angular or whatever you want to use to serve to your users. And if it's testing, like if you are just testing whatever you are doing and you just want to share it with your internal team, like developers or all of that, just use Streamlit. And when you want to like push it, then of course wrap it in a Flask API or wrap it in an actual, fast API, which is better and faster. I actually did wrap it in Fast API later on when I was playing around with the Streamlit, but because I already like prepared the whole thing with Flask, I shared the Flask one with you as it was ready from end to end. Do you have any more questions? Okay, so thank you everyone for being here. And I hope you enjoyed the session and learned something new. See you.